Developing process control charts is not difficult. Let's look at problem 19 on page 934, and I'll show you an example. So here we have some data that shows temperatures that are measured in this particular process. So in each case, this is the average of 5. So apparently they want this process to maintain a constant temperature of 95 degrees centigrade. And they measure, they take temperature measurements 5 times during some given amount of time, and then they average them together. And in each case, this is the average of 5 temperature readings, and this is the average of 5 temperature readings, etc. So that's X bar, and we have 20 examples. So we can consider this a sample of 5. Okay. And this is the range of the samples, or the difference between the high and the low. So there's a 1 degree temperature range, a 0.9 degree temperature range, etc. Now what we want to do is we want to figure out what the upper and lower control limits are for X bar and for R, so that we can tell if this process is in control, or if we have a problem, we need to stop the process and fix it. That's the whole point. So the first thing we're going to do is we're going to take the average of the X bar. We call that X bar bar. So I'm just going to take the average sample mean and the average sample mean is 95.4 degrees. And then I want to take the average range between the high and the low reading in each sample. And the average sample range is 0.67. Now I can use those just to apply a formula and figure out where we are. I'm going to do a little more than is required in this particular question, just because I want to chart it. I want to put it on a chart so you can see what it looks like. So the first thing I'm going to do is I'm going to figure, I've already figured what X bar bar is, and I'm just going to copy that up here, and I'm going to make it constant. The reason I'm going to do this is so that I can draw a line on a chart. Okay, so X bar bar is 95.4. That's just the average of all the sample means. Okay, now I want to compute a lower control limit and an upper control limit. And in order to do that, I need a variable called A2, which I'll take from a chart in your book, which is on page 915. You can also get it on the internet. But this A2 number is based on the size of the sample, and the sample size is 5. So I just look on that chart under A2, sample size 5, and the number that I get is 0.577. Now to use that to identify the lower control limit, the formula is just equals X bar bar minus A2, which is this, times R bar, which is this. Okay, so that's the lower control limit. So the lower control limit is 95.014 degrees. Okay, now I'll calculate the upper control limit. The upper control limit, it's basically the same formula. It equals X bar bar plus A2 times R bar. Okay, so what that means is that if the um, if the sample mean or the average temperature in each sample is between 95.014 and 95.782, then the process is in control. If it's less than this or greater than this, then that means that the process is out of control and there's something wrong. We need to fix it. Usually what that means is we need to stop the process to fix whatever's wrong. Okay, now, just like I copied this down so I could make a line on a chart, I want to copy this down so I make a line on a chart. We've already done all the math, so there's really nothing to it. All right, so then what I want to do is, if I want to chart this whole thing, I can just highlight this. This is my actual measurement, and then highlight this over here, like so. Oops, let me start over. I missed one. So I'm going to highlight this, and I want to highlight all three of these. Okay, and then I'm going to insert a line chart like so, and then this is my control chart. Okay, and I could call it X bar control chart. Okay, what this shows is this is my X bar line. So this is our average temperature, and these are my actual temperature readings. So this is X bar. This line up here is the upper control limit, and this line is the lower control limit. So all the readings would have to be in between these two areas here. And you can see that this process is not in control because on two occasions, on 17, right here, I have one that's below the lower control limit. So the lower control limit is 95.014, and I've got one that's 94.82. So I'll just highlight that. Okay, so that's a problem. And I'm a little above the upper control limit over here, that's 11. Okay, so the upper control limit is 95.782, and in sample number 11, I have 95.8. So both of those two are out of limits. Okay, everything else is in the limit. So I would have to say that in this particular case, this process is out of control and needs to be fixed. Now let's look at the R chart. So I want to see if the range is in control. So the not only does the sample mean need to be within certain limits, but the sample range needs to be within certain limits too. So I just copied this as the range down here. Now I need to calculate the upper and the lower control limit. First I'm going to calculate R bar, which is this number right here. This is the average sample range. So just like I did before, I'm going to say that this equals this, and I'm going to copy it down. Now the lower control limit for R bar just equals R bar times D3, okay? And D3 again is a number that I got from that same table. This is it. And it's 0, so I can see that the lower control limit is 0. So, you know, that makes sense. The lowest range that I'd want to have is no range at all. They were all exactly equal. That's my lower control limit. And my upper control limit just equals R bar times D4. And I'll make that constant. Okay, so as long as my range is between 0 and 1.406, then the process is in control. Obviously, it can't be less than 0, but if the range is more than 1.406, then it's out of control. So I'm going to chart this also. I'm just going to insert. Here we go. Here's my chart. And this is my R bar, or I'll just call it range control chart. Okay, so here are my sample ranges. This is my lower control limit at 0. This is my upper control limit at 1.406. And we can see that all of the sample ranges are within the limits. There are no observations that are outside the limits. Therefore, in regards to sample range, the process is in control. But in regards to sample means, the process is out of control. So that's all there is to it. It's not difficult. This is something that's used widely in manufacturing in terms of quality control, Six Sigma type operations. There's a big demand for people that can do this and understand it. You can see that it's really very simple. I hope that helps.